RGB sir.
Good morning, sir. Tell sir, calling you. So just 1 minute.
Sir. Okay, sir. After he join, we can start, sir.
Yes, sir. Okay, sir.
Students kindly wait. Principal will join.
Hello, ma'am. Principal sir has
Okay, sir, start. A warm good morning to one present here. I heartily welcome you all for the webinar, MATLAB, an overview and its application.
Apart from that, we can carry out a lot of technical sharings among the students. So, the two, when we are combinedly doing this two department purpose will be served. So I hope all the students will involve in this club activities. Each and everyone should give their contribution for the technical sharings mutually. And I just welcome our chief guest also in this webinar. I hope a lot of people will get eye opener. It may be the eye opener session on this particular club. I wish.
So I hope all my dear students will make use of this webinar. I once again I welcome our chief guest and all the dignitaries and all the coordinators of this concert. Please, dear students, please.
Now I would like to request our respected HOD EEE Dr. B.Ezhilavan sir to give a briefing about MATLAB software to all the participants. Sir.
Is my voice audible? Is my voice audible?
Yes, sir. You are audible, sir.
Respected principal sir, dear vice principal sir, dear faculty colleagues, chief guest Dr. Ezhilavan sir, and distinguished participants, very good morning to one and all. It is a great honor to deliver a short note and brief introduction about MATLAB for this session for me. On behalf of the organizing team of this webinar, I just want to register two things in this short note. First, what is MATLAB and why MATLAB? Second one. So what is MATLAB and why MATLAB? Second one. So what is MATLAB? We know the full form. Hope you have did some of you MATLAB. So hope you all know the full form of MATLAB. Matrix. This was developed during the year 1984. So what is MATLAB? Actually, we all are engineers, and we are going to design a new product even after completing the graduate or during your course of duration within this 4 years. As a design engineer, we should not expect things ready and directly if you are going to
alphabets, numericals, text messages, pictures, video file, audio file, any of your input can be handled by MATLAB. Okay, so this is the best advantage of this MATLAB software. Why? Because in some softwares you can't upload a video file as an input. Okay, whereas in MATLAB you can upload even a video file as an input to the MATLAB. So it can handle all types of data as an input. This is the best thing to do with MATLAB. Other things your staff has already told about the MATLAB. What is MATLAB? How to use it? Okay. So he indicated toolboxes in his session. So you have 90 plus toolbox. Again, the information which I am sharing here, this toolbox is regarding 2013 version, 2013 version. You have 90 plus toolboxes. What's the toolbox now? So each and every individual toolbox has been designed working with. Okay, I think you are familiar with current folder and current directory and all. So I'm moving over here. So workspace. Third one is workspace, which means all my data are stored here. Okay. For example, if I'm going to take A equal to 3, B equal to 2, so C equal to A plus B. So A, B and C values will be stored in my workspace. Okay, just an example I'm giving. It may be of any number of strings. Okay, right? You can have inputs and output data which you are getting in will be stored in our workspace. Okay, and fourth one is a command history, which shows that what are the commands so far you have executed. Okay, it's more than that of your diary. It shows what are the things you have done so far. Okay. So this is the explanation of all these things. What is command window, current directories? Why? Because I think you guys are familiar with that. So I will be telling one colon operator and I will be moving towards my examples. Okay. So this is the colon operator. This is the most important operator in MATLAB. Why it is called as most important operator? For example, if you need to get data from 1 to 1000, instead of typing 1, 2, 3, 4, etc. up to 1000, just you can give it as 1 to 1000, 1 colon 1000, which means take the value start at 1 and end at 1000. Okay. So the colon operator, I have given some examples. If it is taken as 1 colon 10, which means start at 1, end at 10. Okay. So take the values from 1 to 10. So if you are giving us 100 minus 750, so start at 100, end at 50, decrement by minus 7. So it starts at 100, 100 minus 7, 93, 93 minus 7, 86. It goes on and it displays up to 50. Okay. So here I have shown the increment. So next example is an increment symbol. So start at 0, ended by increment by pi by 4. So start at 0. So 0 plus pi by 4 0.785. So 0.785 plus pi by 4 1.57. So etc. up to pi 3.1416. Okay. So here, instead of going to visualization, I'll be moving to my MATLAB. So sorry guys, I'll be moving to between my PPT and MATLAB. Why? Because I already told you that I was not interested in PPT alone. Okay, right? I need to show something. At least 3 plus 2 I have to add and I have to show you. Okay, right? I'm not going beginners. Okay. If you are a well-versed person in MATLAB also, it can be act as you're brushing up your basics. Okay, right? So this is your command window. So here I'm using my MATLAB 2020 trial version. Why I'm using my trial version means if I'm indicating or if I'm telling the students to work with the trial version, what the feedback I'm getting is you are working in a version of MATLAB and asking us to work with trial version, and they think that trial version won't work. Okay, so to tell that, instead of telling that it will work, I'm interested in working in trial version to say that it will work. Okay, right? You can do whatever things I'm doing in trial versions over here. Okay, right? So I already told you. So I have come across toolboxes and my colon operator. So I'll okay, right. A equal, you can give any number. Have given 1:10. Okay, right? It will display. So it is executing there. Can you see your double arrow mark is not present over here? Okay. So it will display starting at 1 and ending at 10. Okay. So it will display now. You need to wait for 1 second. Why? Because we are in online mode and we are sharing your data, both audios and videos. So it takes lots of bandwidth. And my system is working in that. So for the synchronization purpose of MATLAB with your space 3 space 5, you can take any numbers. Okay, close square bracket in a row matrix. Okay, how to create a, because all your consideration will be of sign. If you are going for a message signal, consider a message signal as sine vm cos omega t or vm sine omega t. Okay, right? You will going to generate sine and cos signal. That's it. Okay, okay. So if you are telling us to generation of a wave, so how much wave you are going to generate? Amplitude and frequency is most important. Okay, right? So here, so I'm going to start at 0 and end at 2 pi. I already told you the usage of colon operator. Okay, right? So I'm going to start at 0, end at 2 pi means I'm going to create a 360-degree sine wave. Okay, right? So y equal to sine of x, y colon operator. Okay, right? So I'm going to start at 0, end at 2 pi means I'm going to create a 360-degree sine wave. Okay, right? So y equal to sine of x. Y again. Here can you see I have labeled my figure 1 x. This is my x-axis label. This is my y-axis label. And this is my title of the waveform. Okay, right? So in figure 2, I have not given any my labels. So it is very empty over here. Okay. So it is empty now. So figure 1, I have given my x label, y label as well as my title. So it is displayed over here. Okay. So the stem waveform will be explaining in my output. Okay. I'm waiting for my output. Okay. So next, in my second slide, I have given you what are the colors you can use to create your waveform. Okay, right? And I have given an example also. Okay. So here I have generated one sine waveform and a cos waveform. So again, I have generated from this side waveform, single cycle waveform. So sine waveform and cos waveform. So plot your x comma y. So sine will be in blue color and I have to indicate like this. Okay. So the waveform will be indicated by dash lines. Okay. So x comma z, it is cos waveform and it has to indicate it in hyphen o. Okay. So what are the things you can use? I have given over here. Okay. So these are the symbols which indicates the color. Sorry, here yellow, magenta, C for cyan, and R for red, G for green, B for blue, and K for black. Okay. It is hyperly interoriented over here. So these are the symbols which you can use, and these are the symbols which you can use to represent a waveform. Okay, right. So here, in the first figure, I have generated two waveforms in two different figures. So I have used figure 1, figure 2, and all. Here I have generated two waveforms in the same figure. So I have not used that figure 1, figure 2, and all. Right. So goodness, why it takes this much time? Still it is executing. Let me complete it in my PPT. Whenever my MATLAB works, I will go over there. Okay, I'll be getting a pop-up message over here, then I'll be moving over there. Okay, don't worry. Anyway, I'll be showing everything here. Okay. So this is my second example. So these things you have done in your DSP lab, I think. So if you are working with MATLAB in your DSP, then you would have come across these things. Okay. So this is my second example. And third example is regarding your 3D plots. Only when I go to my slideshow. Okay. So this is my 3D vision command. So this command is used to indicate which is sin x and which is cos x. Okay, right? It will indicate which is sin x and which is cos x. Okay. So MATLAB supports 3D plot. I already told you you can do your 2D as well as 3D. I'm not going to waste my time. Just one example or one simple example using 3D, and I'll be moving to my next slide. Okay, right. So plot 3 is the command used to create 3D plots. I'm going to tell about this only. Okay. If you're going for mesh, surface, and contour, if you're going to use your graphical user interface, then you must know your mesh, surface, and contour. Okay, the basic example of your GUI comes under this one only. Okay, right? So it doesn't mean you have to do that, but it is the basic of GUI. Okay, it is better to learn that. That's it. So okay, I'm going for plot 3 command. Here same thing. So 0 to 10 5. So 5 cycles it will be generating. So sine and cos. So plot 3 x comma y comma z. So 3D graph is being shown over here. Your dotted lines. Okay. So my MATLAB is running over there. Wait, I'll be moving over here. So these are the functions which I have used, and these are the explanations of this which I have used over there. Okay, right? So operators and control flow. Before going to operators, let me complete my where my figure one. Oh my goodness, just now I got it. Still it is in running case. Okay, right. So can you see this is my figure 1 and this is my figure 2. Okay. Okay, that's it. So here I have generated from 0 to 360 degree of amplitude 1, and here it is generated of 0 to 360 degree. Here I have used my stem waveform to indicate the values of 30-30 intervals. Okay. So I have given pi by 6, 180 divided by 6, it will be of 30 degrees. So sine 0, sine 30, sine 60, sine 90. Okay, 120, 150, 180. Okay. If you keep your cursor over here, it will display the value, but presently it takes time to display. I'll be moving over here. Okay. So here I'm interested in generating some 10 cycle waveform, 5 cycle waveform with an amplitude of 10. Okay. Now I think now, so let me see. Okay. It will display. I have not done any changes in my figure 2. Just I have changed my figure. Okay, it doesn't mean only generation of waveforms can be done in your M files. No, not like that. You can do each and every work can be done in your MATLAB. For example, I think you would have, I don't know whether you have come across in some, it is time consuming, but anyway, I'll tell you, if you are coming across your tank overflow problem, even that kind of problems can also be solved in your M files. Okay, right? Simple problems can be solved using your M file. Even your wavelet typed communication problems can also be solved using M file. Okay, I think you will be familiar with the M file only. Okay, so if you are familiar with M file, you can go for graphic user interface. So become an older version for MATLAB. So they have created new thing called as user interface (UI), okay, right? And app development, a thing which you are done in MATLAB, okay, right? App designer or app development is the advancement of your guide or user interface case. You can do the same thing with switch case also, okay, right? Same example can be done with switch case. So instead of doing the same example, I have taken a 3 case example, okay, right? So divide number by 3, okay, right? If you divide any number by 3, what are the possible cases? The remainder will be 0, the remainder will be 1, the remainder will be 2, okay, right? So for this thing, I have used over here. So this is switch case, remainder of case 2, the remainder is 2, otherwise not possible, okay, right? When this error occurs, ma'am, if you are giving as n equal to a, if you are giving any alphanumeric values or if you are including any text files or if you are inputting any video files as an input, then you will be getting as error not possible, okay, right? So this is the thing which are happening in loops and all. So now I'm going to Simulink. I think even if you are in final year students also, you'll be getting somewhat new to the Simulink. I think so. Okay, right. So I already told you how to open the Simulink. Okay, right. I have shown you the symbol for Simulink. If you click that, you'll be getting an untitled Simulink block. In that symbol for Simulink library browser. So this slide I have taken from 2018 MATLAB. Okay, right? This is regarding 2018 version. So I am using three versions of MATLAB. I have 2013, 2018, as well as 2020 trial version. Okay, right? So I'm using three versions in my same laptop. Okay. So if you need to go for a best version, then you have to go for 2020 only. Okay, right? This is very latest. Everything has been updated. Okay, right? Best version of MATLAB 2020 to work with. Okay. So here I have shown you my library browser. These are my toolboxes. Okay, right? These are my toolboxes. You have n number of toolboxes over here. So this is my untitled Simulink. How my untitled Simulink will be. Okay, right? So here I'm going to have two examples. One is basic of example of your diode based example one, and second one is going for an upgraded version like solar. Okay, right? I'm going to show only two things. If time permits, I'll be starting from zero. Okay, right? How to open, how to create, where to get your files and where to place it. Everything will be I'll be telling. If not, I'll be showing my results in MATLAB. Okay, right? Let us conclude that. Okay. So Simulink, you can. What is the difference between M file and Simulink? In MATLAB, you can work with n number of applications or n number of files. Okay, right? First one is using M file, and second one is using your Simulink model, and third one is using graphical user interface, and fourth one is by using your user interface, and fifth one is app designing. Okay, right? So this, you have to go one by one. Then only you have to. Then only you can work with your advanced versions. Okay, right? If you are going for graphical user interface, your M file as well as your library browser. Okay, without knowing these things, graphical user interface. Okay. So this is, I have a simple example of half-wave rectifier. Why I choose this half-wave rectifier? I think this is the first thing you would have read in your engineering stream. Okay, first thing you would have read is diode. What are the characteristics of diode? It is made up of semiconductor. What are the semiconductor available? What are the two types of semiconductor available? Which one you are using? Okay, so so that's why I have gone. Okay, right? So this is the current. So now you know that what are the parameters and where to take all these components. Okay, right? Now I'll be moving to my MATLAB. At least simple example I have to show you. Okay, right? So here, I have already drawn here. Okay, right? I'll be moving to this as well. So can you see this is my source block? I have used an AC source, and this is my diode, and this is my load. Okay, right? I have used my RL load. Just I'm going to change this as R load. Okay. It takes time. Oh my goodness, the synchronization problem is the problem for me. I'll be closing the things which you are not interested in. Okay, which I have already used. It may increase my speed. Okay, right? I'm interested in showing you the basic things. Then I'll be moving with solar. Okay, right? This is my solar panel. Time by month, I'll be showing you all these things. So here, I have used an RL load. Wait, I'm trying to change this. Okay, right? Nothing changed. Okay, right? This resistance I given a resistance. You can take it of any value as you wish. Okay, right? Since it's just an example to study with. Okay, right? So my first moved resistance. Okay, right? So this is my source, this is my diode, and this is my resistance block. I have already told this is my voltage measurement. This is my voltage measurement used to measure the output voltage. This is the voltage measurement used to measure the input voltage, and this is the current measurement used to measure the current. Okay, I have given n number of scopes. I think so. Okay, right? I'll be deleting all these things because maybe. So this is to view my input voltage alone. Okay, so I'm deleting that one, and this is to view my current alone, and this is to view my voltage. Okay, I'll be deleting. If needed means so I have told you how to create a new model. Just you click this, it will be creating a new model. Now, where to find all these blocks to do it? Okay, right? I'm doing this for an user. Okay, right? If you are already know this, I'm very sorry for you. So I'm specialized power systems. So here I'm going to go for fundamental blocks. Okay, right? So this is your SimScape library browser. You have to build your file using this one. Okay, right? So these are the toolboxes available. In that, I'm going to go for SimScape. Okay, right? If you click SimScape, will be having both electrical components as well as your power system components. And here I'm going with power system components. Why? Because I'm from tricky background. Okay, right? I was familiar with these things. Okay, that's why I'm going over here. Don't worry, I'm from ECE, B from ECE and ME from Triple. So I'll be doing both the things. Okay. So electrical sources, you will be having sources here, right? From this, just drag this voltage source to your untitled block, you'll be getting this voltage source. Okay, right? Again repeating, I'm telling where I have taken all blocks. So go for SimScape. Go for SimScape. In that SimScape, select your power systems. In that, select fundamental block. You'll be getting your sources. Okay, right? So next one, you need measurements, right? Voltage measurement block. So here you can see this is current measurement, and this is voltage measurement. Okay, right? So you'll be having your multimeter out of here. Okay, right? If you know to use multimeter, then you can use it. So I'll be going with basics, I think so. Okay, right? So this is voltage measurement block. This is current measurement block. So just drag this over here. You'll be getting that one. Okay, right? So next one is diode. Okay, right? Everything over here. Full bridge converter. Can you see? GTO, half bridge converter, ideal switch, IBT, diode, MOSFET. Okay, everything was available over there. If you are using your 2018 version, also some parameters or some blocks are missing. Okay, right now 2020 it is very much updated. Okay, you have n number of blocks over here. Okay, so here I have taken my diode from here. Okay, right? I have just taken my diode from here. So source is taken from electrical sources. The main component diode is taken from power electronics. Load. Okay, right? So load is taken. So far I have shown all the components. What is this? This is power grid block which acts as a power to this simulation. Okay, right? Only in this point you will be having a difference between ECE as well as Triple. Okay, right? So these components, the same components will be available in ECE also. I'm just showing that. Whereas they will be, so here it is in black in color. Whereas if you are going to use components from, okay, right. This is components from okay, right? So blue color indicates I have taken these components from EC sites, and this black color indicates I have taken components from power system side. Okay, right? If you are using this blue color components as a main component, then you have to go for solver blocks. Okay, right? This is called a solver block. Okay. Solver configuration. If you are connecting this only, your simulation will run. If you are going to use this power system as the main box, then you have to use power guide. Okay, right? I'll be showing where is power guide as well as where is okay, right? So if you go for simple system, so power system, fundamental block. So can you see power guide? Just drag this over here. You'll be getting this. Okay, right? If you are going to use elements from this, if you are going to use elements inside power systems, then you must necessarily use your power guide block. Okay, right? Else, if you are going to take components from this one, so can you see the sources over here? So only indication is it will be in blue color. Can you see the color? That's it. Okay, right? If you are going for that this components from your electrical side, then you must use your configuration block. Okay, right? So if you know the name, just you can type over here, and it will search and tell you where it's present. Okay. So can you see here solver configuration? So this is necessary to execute a component from some scale, and power guy is necessary to execute a component from power systems. Okay, right? So here I have indicated a half-wave rectifier. After completing this, review file and you can run it. Okay. So let me run this file. While running, you can have two indications. First one, you'll be getting a blue here. Okay, it indicates that it is running. Second one, what you can have. So the name of the program, right? So still it is an initial state. It is not in running state. Okay, right? If I click more than twice, click more than that. Okay, right? Click more than that. Okay, right? I'll be waiting for the execution. Okay, right? So this is regarding your diode. Okay, right? So what's there in this, ma'am? You're going to just build it. No, not like that. You can analyze the properties of each and every component. What happens if you are using a resistive load? What happens if you are increasing the resistance? What happens if you are decreasing the resistance? Second one, what happens for your RL load? Okay. So what is the use of an inductor over there? So if you are switching from resistance load to inductance load, obviously so can you see here it is in running state, it is in 2% running. Okay, it will be compiling. After compiling, it will be getting running. Okay, right? So it takes some 1 to 2 minutes. Within that, I'll be explaining all these parameters. Okay. So okay. So what are the property of inductor? Okay, right? It shows that it stores some value. If you change in direction of current, what happens to my inductor? Okay, right? So if you are increasing the inductor values, what happens to the output? If you are decreasing the inductor value, what happens to your output? Okay, right? So each and everything can be viewed over here so that you can fix if you want a waveform or if you want output like this. So what is my value of my inductor and what is the value of my resistor, what is the value of my capacitors can be done over here. And here I have taken my ideal diode. You can go for spice diode also. Okay, right? Spice diodes and all will be available in your sim cape electric block. Okay. So these things after completing, I'll be opening and I'll be showing my results over here. Okay, please don't worry. So within that, I'll be moving for solar panel. Okay, this is regarding your R load. Only when I move to slideshow, my MATLAB is working very faster, so I'm going for slideshow. I'll be completing my slides and I'll be coming back to my MATLAB. Okay, right? Why? Because it's already time. Okay. So next one. So this is input of my resistive load. So can you see this is my input, AC input of amplitude 200, and this is my output only in positive. Okay. So I have converted my positive and negative waveform to positive. Actually, the output of rectifier is not perfect DC. It is called as pulsating DC. Okay. I have got a pulsating DC. The green color indicates my output voltage, and this blue color small waveform indicates my output current. Okay, right? So this is the rectifier with RL load, just to show you how my inductor works with. Okay, right? Can you see the spike over here? Waveform, right? Okay, the spike is due to my inductor, and my inductor doesn't allows reverse direction of current. Hence, the spike occurs. Okay, so the spike is due to my inductor. Okay, so I'm going to have renewable energy. So you know why we are going for renewable energy and all. I think you know this. The source which is available in large. Okay, right? That's called as renewable energy, and these are the types of renewable energy. Here I'm going to deal with only solar. Okay, right? Why particularly solar, ma'am? Solar can be used by each and every individual. It is very low cost. Okay, when compared to wind, biomass, all your renewable energy sources, solar is very less cost when compared to others. Okay. So from solar, you can take two types of energy. One is thermal energy, and second one is light energy. So thermal energy means heat of your sun, and photovoltaic means light of your sun. Okay, like your sun provides two energy. One is heat and light. Okay, if you are going to use that heat, then it is called as thermal generation. If you are going to use that light, then it is called as photovoltaic generation. Okay, right. So this is the structure of solar concentrated power, which means I think in your smaller versions, have you done with this? I don't know. You'll be having a mirror over there. If you are converging, if you are showing it in your sunlight and you're keeping a piece of paper behind your mirror, the sunlight will be falling on your mirror and it will be converging to a point. If you're keeping for 2 to 5 minutes, then the paper will get burned. Okay, I don't know whether you have worked with or not. I have worked with and I have done this in my uh, childhood. Okay, right? So the same component, same process occurs over here. Okay, so sun rays, these are my mirrors. Okay, right? So the sun rays falls on the mirror and this converges to a single point. Okay, right? The temperature around the receiver will be 400 degrees Celsius. Again, repeating, the temperature around the receiver will be 400 degrees Celsius. Okay, right? And this heat is given to the steam drum. If it is used to boil the water, and this steam is used to run the turbine and it is used to generate electricity. Okay, right? So second one is you can use this heat to generate or you can use this heat to evaporate or your heat your liquid, whichever you want. Okay, right? So this is the working of solar concentrated power. So I have explained this here. So solar cell, it is nothing but a semiconductor in junction diode. When light falls on your photo semiconductor, the free electron absorbs that light energy, electrons move in conduction band, there is heat. Okay, right. So this is the thing which I have explained over here. So sun rays falls on solar panels, so absorbs light from the sun, and the electron absorbs its light energy and they move over to your conduction band. Hence, the movement of a flow of electrons occurs, which means the electricity flows, and that that charge can be stored in your batteries and it can be given for DC powers, and that charge cut to AC by using an inverter and it can use for AC loads. Okay, right? So this is the example of a solar. This is an example of solar cell, and I have given a characteristics of solar cell. Okay, right? The solar cell, your solar cell works on two input parameters. One is irradiation, and second is temperature. What does irradiation mean? It directly means that intensity of light. Okay, right? And what is the intensity of light you are getting? That is called as irradiation. Temperature. What is the temperature you are working, or what is the temperature of uh, so temperature around you in your temperature? You have two input, one is irradiation and temperature. Depending upon your irradiation and temperature, right? So here I have used a solar cell. It's a single solar cell. This is only one solar cell. If you are connecting in series and parallel, you can create your solar module. Okay, right? So I have created one. I have used only one solar cell. Okay, right? So the value of irradiation can move from 0 to 1000 as set of your from 0 to 1. Okay, right? Similarly, your irradiation can be 1000. Okay, this is the irradiation level you can work with, and your temperature in India will be getting temperature between some 15 to 40. Okay, right? That is the most probably used temperature. So you can work with 20 to 40. Maximum will be having temperature of 20 to 40. You can increase the temperature as you want in which world or which. Right? Since we are in India, you can work from minimum temperature of 20 and maximum temperature of 40. Okay, right? So here I have got the PV characteristics. This is output power, this is the output voltage for different temperature and different irradiations. Correct. From this you can see this is my topmost value. So this yellow color indicates over here. Okay, right? So the irradiation is 1000 and the temperature is 20 degree. If you have maximum irradiation with less temperature, your output voltage is good. Okay, right? That is the thing we are going to use with here. Okay. So second, okay, now I'll be moving to my MATLAB. So in that MATLAB, I'll be showing you my results and I'll be concluding it since of time. Okay. Fast, too fast. Okay, here it is in running state. Let me done. Okay. So here I have solar cell. Okay, right. So here I have used a solar cell which is available in my SimScape. It is in blue color, which indicates it is available in electrical systems. Okay, right. So this is my A shows the current sensor and B shows it is a voltage sensor. Okay, right. So this is A shows my current sensor and this is my voltage sensor, and this is the variable temperature. Okay, right. So I have given variable temperature, and this is irradiation. I have given 1000 irradiation. So this output current is measured over here, and this output voltage is measured over here, and my voltage and current are multiplied to get the power over here. Okay, right? So I have drawn the VI characteristics and PV characteristics of your solar. Right? Here I have used the 5 solar connected in series. Oh my god, series are parallel. I forgot. Yeah, I have connected in series, I think so. Okay, right? I have connected 5 solar cells in series, and can you see 1, 2, 3, 4, 5? Okay, right? Have a series connection of solar. This is positive PN junction. This is your equations. Okay, right? That's it. Okay. After that, after knowing your M file and your Simulink, then you have to go for mathematical modeling. Okay, right? Mathematical modeling means you'll be getting a differential equation, partial differential equation, and that differential equation you have to create that equation using your Simulink. Okay, right? All the parameters I have shown you now. Using the blocks available with the library browser, you have to create the model using your partial differential equation. That is most probably your mathematical modeling. After completing that part, you can go for your graphical user interface, GUI, and after completing that, you can go for your user interface. Okay, right? So it is compiling over here. So what's the disadvantage of MATLAB, ma'am? What is the advantage of MATLAB? Both. I am going to deal with what is the advantage and disadvantage. MATLAB means it is not meant for a particular team, so everybody can use your MATLAB. So this is the basic advantage of MATLAB. Okay, right? It is platform independent. It is easy to use. These all the advantage of MATLAB. What is the disadvantage? Two things. One, it is somewhat slower, and second one, it is expensive. Okay, right? And then last, I have to conclude speed and cost. Okay, right? Why? Because I am teaching MATLAB and I couldn't say that it is very negative. Okay, right? So your speed of the MATLAB depends upon the configuration of your system you are using. Okay, right? If you are going with good system configuration and you have installed your MATLAB alone, then it will be in good speed. Okay, right? Here I am using n number of MATLAB versions in my same system. So I'm getting the speed and the synchronization problem between my online to offline. Okay, right? These are the problems I'm getting over here. Okay, that one. And it won't say that it is that much expensive. If you are in a student version, you can get it for $60. Okay, right? And you can add each and every toolbox by $5. $5. You can add each and every toolbox. What are the toolbox you need? Okay. So if you're interested in working aerospace, you can add your aerospace toolbox for $5. Okay, right? The student version will be available below, and for adding each and every toolbox, you need extra $5. Okay, right? And you can get it from mathworks.com. Okay, right? Again, I'm telling mathworks.com. It is the official website of MATLAB. MATHWORKS, mathworks.com. Go for mathworks.com. Create an account using your mail ID, and you can go for your trial version. Your trial version of 1 month. After 1 month, what to do, ma'am? Again, download your trial version and use it. Okay, right? You can download for n number of times. Okay, there is no limitations to download your trial version. Another thing, if downloading and installing of MATLAB will take some time, as well as it takes some data also. Okay? You need from hardly 10 to 12 GB. Regarding of choosing of your toolbox. Okay, if you're choosing many toolbox, you need extra data and extra time. Okay, right? If you are okay with one or two toolbox, you need less data and less time. Correct. Yeah. Regarding your data, if you can't spend that much data in downloading and installing, you can go for online MATLAB. Okay, right? You have a trial version of online MATLAB, but just go and click your MATLAB will be open in online. For that, if you are going to work in MATLAB, you must be in online. That's it. That's the needed criteria. If you can't see that I couldn't go for PC also, then you can go for mobile. Okay, right? MATLAB is available in mobile version also. It is the Facebook app. It is available as MATLAB app. Okay, right? You can go and download in your mobile MATLAB app, and you can use in your mobile also. Okay, it is that much user friendly, and you can do n number of applications in MATLAB. Since this is my first session, I couldn't go straightly to my application designing. Okay, right? I just need to tell at least a similar or basic of my all files to be used with. Okay, that's why I'm telling these things. And if you have any queries, you can ask me. And it is still compiling. Okay, you can ask questions. If time permits, I'll be showing you the results. It's still in running case.
Students, you can post your query or unmute yourself and ask the questions.
You can use your chat box also. I'm using this. You can view my screen, I think so. Okay, right? And actually, it needs some data. At least minimum some 5 GB data is needed to download a basic version. Okay.
Okay, and for online also we can use like any open platform. Yeah?
Ma'am, I couldn't hear you.
You have told that we can use online coding also. So in that coding part is also available as well as simulating part is also available.
Yeah, both is available, ma'am. Both is available in your online MATLAB.
Okay, okay. Actually, previously I was working. I just know that we have to download and the system it has to be that much GB to work on.
Obviously, if you are going for MATLAB, your system speed will reduce. Okay, that's the disadvantage of MATLAB. Yeah, nothing can be done with that. But now you can go for online MATLAB. The only thing you must be in online. That is the only thing if you're going for online MATLAB.
Oh, okay, okay. I guess started new. Some years I have not worked on that.
Yeah.
The session, ma'am, it was very well. It was. I hope the student will find it so beneficial because you have started from basic completing coding part as well as simulating part as well as you have shown some basic models of rectifier as well as the solar panel. It was very useful. So students, I'll be posting your chat box or you can unmute and ask to ma'am directly. Okay, then I'll request the coordinator, Dr. R. Ganesh Babu, to deliver a vote of thanks. Sir, please.
So good afternoon, everyone. I take this opportunity to propose vote of thanks for today's webinar, MATLAB and overview and its application. First, I thank our webinar speaker, Dr. B.Ezhilavan and A. Devi ma'am, for enlightening us their knowledge. Today's webinar gave deep insights into the topic and also revealed the precious knowledge. I'm pretty sure the precious knowledge they gave us will definitely help us in our studies and future. I would also like to thank our principal sir, executive director sir, deputy director sir for giving permission to organizing this webinar session. Once again, I especially thank our vice principal and head of the department of ECE, Dr. B. Ramasubramanian sir, and also like to thank head of the department of EEE, Dr. B.Ezhilavan sir, and both department faculty members for their unflinching support and coordination. Our heartfelt thanks to our students for their active participation. Thank you.
Thank you, sir. Students will Students will be sharing the PPT with all the participants through mail, and we'll request that just try to practice the session. Coding with ma'am.
Feedback level.
Okay, just wait. I will share the feedback with everyone. I posted the feedback link in the chat box. You can submit your feedback, and then you'll get your certificate on your mail. Okay, students, just submit your feedback, and you can leave the session. Students, you can leave the session now. PPT will mail you. can fill the